An unexpected discovery was made by the James Webb Space Telescope, city lights in space located 7 trillion miles away from Earth. This remarkable finding has sparked curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri b? Could this indicate the presence of life beyond our planet? Scientists are delving into how the James Webb Telescope detected these extraordinary phenomena in space. For years, scientists and the general public have waited and researched to catch even a glimpse of life beyond our solar system. Any evidence perceived to support this dream has long been welcomed with enthusiasm. Recently, the scientific community was taken by surprise when seemingly solid evidence of life forms existing in space was observed by the James Webb Space Telescope. While exploring outer space and relaying vital information back to Earth, the telescope noticed strange city-like lights shining from the exoplanet Proxima Centauri b. These lights resembled those illuminating a distant city, leaving scientists astonished. The possibility of an alien city existing on this exoplanet has caused intense speculation. If this turns out to be true, it could mean that intelligent life forms have built civilizations in outer space and existence humans are only now discovering. Looking into these city-like lights located 7 trillion miles from Earth, NASA engineers are left wondering how long these lights have been glowing in space, possibly waiting for humanity to develop the technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet as particularly tricky. He says this because the star system, being the closest to Earth, has varied heating patterns that differ from other planets. Typically, rocky planets absorb sunlight and emit infrared radiation. However, Proxima b's infrared nature behaves differently from that of its host star, Proxima Centauri. This difference makes it an ideal subject for observation by the James Webb Space Telescope JWST. The telescope excels at detecting infrared wavelengths, and Proxima b's distinct heat signature could be key to uncovering the secrets of its atmosphere. With its advanced infrared imaging capabilities, the JWST allows scientists to explore these mysteries further. They plan to use the telescope to study the planet's atmospheric components and assess its habitability. The JWST's infrared sensitivity enables it to explore Proxima Centauri b's nighttime, detecting the faintest rays of light in cosmic darkness, something most other space telescopes struggle to do. The telescope is capable of detecting artificial illumination in the cosmos, as long as the light falls within a frequency band 1,000 times narrower than starlight. Proxima b presents a compelling interaction between its surface and stellar environment. The day side of the planet is said to have solar panels that harness radiant energy from the host star, while its spectral edge reflects incoming light. As Proxima b orbits Proxima Centauri, it experiences day and night cycles similar to Earth, with daytime absorbing solar heat and nighttime bringing cooler conditions. Proxima b is known to have temperature fluctuations influenced by its composition. If it lacks an atmosphere, there would be a stark difference between its day and night temperatures. Without atmospheric gases or oceans to moderate the climate, the day side could become extremely hot, while the night side would plunge into frigid darkness. These temperature differences offer scientists valuable clues about the planet's atmospheric makeup. With unmatched infrared imaging capabilities, the JWST can efficiently examine Proxima b's thermal emissions to deliver data on its atmospheric properties. Interestingly, the orbit of the James Webb Telescope aligns well with Proxima b's orbital period, allowing full observation of the exoplanet's day and night cycles within just 11 Earth days. Now that it appears the planet does have an atmosphere, scientists are shifting focus to analyze its atmospheric chemistry for life-supporting elements. Key indicators include the presence of gases such as oxygen, water vapor, and methane. If these elements are detected, they could point to conditions favorable for life. Determining this is not an easy task. Even though the JWST has advanced capabilities for characterizing planetary atmospheres, its primary focus is analyzing variations in water vapor, carbon dioxide, and methane concentrations. When it comes to identifying bonded oxygen, a crucial sign of life, the JWST is somewhat limited. Nevertheless, the telescope still has good reason to search for other elements like ozone, which offers another strong indicator of biological activity in the atmosphere. It's important to note that the James Webb Space Telescope doesn't have unlimited capabilities. It can only study a few of the closest potentially habitable worlds. To conduct a more comprehensive atmospheric analysis, astronomers are turning to ground-based observatories like the extremely large telescope ELT, set to begin operations in 2028, positioned to probe deeper into the atmospheric structure of distant exoplanets. The ELT is expected to generate rich data that could expand our understanding of their habitability. NASA scientists and researchers eagerly await the deployment of such future space instruments. Until then, the James Webb Space Telescope remains a central tool in the exploration of distant planets. Despite its limitations, the JWST offers profound insights that could transform our understanding of exoplanetary systems. Future space telescopes are being designed with the goal of minimizing the overwhelming brightness of a planet's host star. This can be done using internal masks or large external structures shaped like umbrellas to block out the star's light, allowing scientists to better observe the planet itself, similar to shading your eyes from the sun to see an object more clearly. This method will help future telescopes detect the faint reflected light from distant exoplanets, improving the analysis of their atmospheres and their potential to support life. However, this approach comes with its own challenges. Scientists must be able to distinguish between gases produced by life and those generated by geological processes, such as volcanic activity. Astronomers are committed to refining our understanding of exoplanets so they can more accurately detect life and avoid false positives. The James Webb Telescope represents a preview of the next generation of scientific breakthroughs in the study of exoplanets. As we expand our exploration of the cosmos, we deepen our understanding of the universe and our place within it. Despite decades of searching, scientists have yet to find a planet that definitively hosts life. The search continues. For millennia, humans have wondered whether they are alone in the universe. This enduring question still captures the imagination today. Even now, the James Webb Telescope is positioned in space, scanning the skies for hidden alien civilizations and examining planets for signs of life. A popular theory suggests that intelligent alien life may already exist in the stars, simply waiting for us to discover them. To address this mystery, American astronomers Jill Tarter and Thomas Pearson launched a project in 1980 called the Search for Extraterrestrial Intelligence SETI Institute. This nonprofit organization focuses on detecting radio signals from space, as radio waves can travel long distances without being scattered or absorbed, unlike other forms of radiation. Because of this, they are more likely to be captured by instruments such as the 42 radio telescopes that make up the Allen Telescope Array, located in the Cascade Mountains of California. Despite decades of monitoring, the SETI Institute has not yet detected any verified radio signals from alien civilizations. Jill Tarter remains optimistic, expressing a desire for people across Earth to take an active role in the cosmic search for intelligent life. In her words, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." All of this continued until recent reports from NASA suggested that the James Webb Space Telescope may have observed what appeared to be city lights on a planet near Earth. The JWST has become one of humanity's most powerful tools for understanding the universe. Positioned about 1 million miles from Earth, it transmits highly detailed information about the early universe and is designed to reveal hidden details about the formation of galaxies, stars, and planets. Its mission is to uncover facts that were once beyond our reach, and with each new discovery, we move closer to answering one of the greatest questions of all time: are we alone?